The world's climate is changing. The sea level is rising. The ocean is warming. More heat to fuel the hurricanes that put us in harm's way.
The hurricane is the greatest storm on Earth, and it's capable of doing tremendous damage and causing large loss of life.
Is it possible that losses inflicted by the weather of the future may be even greater than those of today?
The changes that we're having on the planet as a whole could be affecting the frequency, the severity of these hurricanes, and I think that's something to be extremely concerned about in the future.
To prepare for our weather fate, science searches the past for clues to the long-term trends in storm events.
So by studying the past, we hope that it can help us better understand the present and to better predict the future.
With the planet's evolving weather, how well prepared are we to survive the hurricanes of the 22nd century? Over the ocean, a new storm gathers strength, churning towards land. In what weather world would such systems move 100 years from now? Predictions of future climate have won climatologist Jean-Pascal Van Ypersele a Nobel Prize for Science.
Well, climate is going to change in the next 100 years, mostly through the effect of human activities and greenhouse gases. And the main change is an average warming of the temperature at the surface of the planet. And there'll be changes in the Atlantic storm activity.
Just how those storms do change concerns scientists and forecasters of the hurricane research community in Miami, Florida.
There is still significant debate about how hurricanes may change as climate changes.
There are modelers who are running 100-year scenarios that clearly show that the potential energy available for hurricanes will become greater.
Most of these climate models are saying that we'll have fewer numbers of storms and hurricanes as the climate warms. But then people also say that hurricanes are becoming stronger.
The strength of the landfall of Hurricane Sandy made it the second most expensive hurricane of all time. During the night of October 28, 2012, it would change the lives of thousands.
This is part of the Brick Township's 3.5 miles of the Barrier Island, and this is the aftermath of Superstorm or Hurricane Sandy. That house that you see behind us here was actually up by the beach, and that came down. So there's a truck underneath this house, obviously the forklifts that you see, and just the force of the water is really unimaginable, because when you look around and you see the devastation, never before I've lived here all my life, would I believe that I'd see something like this.
Despite its great size, this was a modest Category 1 storm, a deadly storm. But was it the superstorm of the future?
We were here for Irene last year, and the water came up to the edge of the boardwalk, never went any further, and it really didn't do any damage. There's been people that have been down here a lot longer than myself. They said they, in all their years, 50 years, have never seen anything like this, and you can see what it did. It had to be something, again, that no one could have ever expected to do this kind of damage.
If the storm only had relatively weak winds, why was it so destructive?
Sandy was producing Category 1 hurricane force winds, but it was such a large storm. Its area of tropical storm force winds extended from the Carolinas up through much of New England. When we're talking about storm size and storm surge, it's very important to think about how the storm is pushing this water on shore. If you take your hand across a swimming pool and push just a little bit of water, it doesn't move very much. But if you take your entire arm across the top of that swimming pool, you'll push a large amount of water. And that's what we're looking at with storm sides.
So it is not simply how often future storms would strike, but how damaging they will be in terms of size and power. Satellites encircling the planet collect the best data for computer models of future hurricane trends.
Do we have more tropical storms and hurricanes in the historical database now than we did years ago? Absolutely, yes. And the reason for that, in my opinion, the primary reason for that is improvements in observations. I mean, if you think about it, before we had satellites, how did we even know we had a hurricane out in the middle of the Atlantic Ocean?
Satellite measurements were not available before with a good quality, and therefore we only have a relatively short record to talk about the trends in hurricane activity.
Official weather records only go back about 160 years. To extend our data set of when and where hurricanes have hit, we need to look deeper into the past.
Okay, that's about it.
The last 160 years is too short for us to understand the frequencies of very intense but very rare hurricanes, and that is why we try to extend that record, that period of observation, from 160 years to 2,000 or 3,000 years, so that we can have a longer period of time during which more hurricanes like Katrina did happen.
Okay.
But the past does not give up its secrets easily.
And so part of the objectives of our work here is to try to find evidence of ancient hurricanes and try to reconstruct their frequencies during the last hundreds or thousands of years.
The team are looking for traces of sand layers in the muddy swamp deposits, telltale signs of a powerful hurricane in the past. The soil itself serving as a natural archive of thousands of years of weather events.
Well, when we open our core, we expect that the storm surge deposit will have a different character visually, because the mineral and chemical composition may be different, and also the storm surge deposit may be of a different texture. Now you see this root here that's lying horizontally. It could have been washed in by water, but just looking at the color, you see it's very different. This is most likely the Hurricane Isaac deposit, and it may go from here down to about here. But when we come down to here, then we can see the silt and clay laminations, beautiful layers of, darker bands and lighter bands. This material might be several thousand years old.
By analyzing many cores sampled across an area, they'll be able to find out how often big storms have occurred.
We found that the most intense hurricanes, like Category 4 and 5 hurricanes, they have a typical rate of hitting the same site maybe once every 300 years or so.
The study of cycles of hurricane activity over time is helping geologists and climatologists to form a view of future climate trends.
Assembling all that information gives a relatively complete picture of how climate has evolved in the past. And that's very useful to validate the climate models in order to have confidence in them when they are used to look at the future.
Complex computer models lead them to believe that hurricanes may actually become less frequent, but that it is not the full picture.
In a warmer climate, hurricanes might become more intense, even though they would become less frequent.
Which means that although there will be fewer storms overall, more of them will be the most damaging of major hurricanes.
A hurricane is still a rare event, and our memories are very short. I've seen a lot of hurricanes even here in Miami. We went through a Category 5 hurricane, Hurricane Andrew in 1992. But with time, people forget what these hurricanes can do.